So let's get started. But before we dive into the world of Python, don't worry if you've never written a single line of code before. We'll keep this fun, simple, and hands on. And by the end of this course, you'll not only just understand Python basics, but also know how real world companies use it to handle massive amounts of data. Grab a coffee if you have one, get comfy, and let's start our journey into Python. Let's get a quick check in. How many of you are familiar with this screen? Do you know where this screenshot is from? It's a homepage of Netflix. What I'm gonna do a case study on Netflix and walk you through it step by step. And in the end, we're gonna see how Netflix recommend the movies. When you search for a movie and it shows you a list of movies that you want to watch, what are the categories? How does it define those categories? Action, thriller, sci-fi, top 10 movies in Canada, or top 10 movies in USA. We're going to cover all those so that we can keep this Python concept interesting. So let's dive deeper into it. Let's start with the basics. What exactly is Python? Well, if we go into the technical terms, Python is a high level interpreted programming language that is super popular because it's easy to read and write. Coming back to Python, let me break it down for you. When I say Python is a high level language, what does it mean? Think of it like Python is really closer to the way humans speak and think. Unlike other languages that are more like secret codes or machine language, interacting with computers in ones and zeros, Python lets you write code that actually makes sense, like talking to a friend in plain English. So you don't have to deal with all complicated stuff like memory management or something other coding languages that are too complicated to write and understand because Python does that for you. It's like making an instant coffee. Just mix hot water and coffee powder, boom, you're ready to go. But with a low level language, that's the opposite of high level, you have to roast beans, grind them, measure everything, and brew it yourself. I mean, who's got time for that, right? So that's why Python is the guru high level language. But what about the term interpreted? Imagine you're watching Netflix. So when you're watching Netflix, you don't have to wait for the whole show to download. You just click on the play button and starts watching. It means Python works the same way. It runs your code line by line, like hitting play on your favorite show, and you can run it and by line. So instead of having to wait for everything to compile and load first, you can test and debug small parts of your code right away. You wrote a line of code, you can test it right away. You don't have to wait for like writing the full set of code and then wait, oh, where was the error? You can write it in chunks. Now, everywhere you Google, if you're into tech world, you might be wondering why Python is everywhere. And so it's not just a random trend. It's actually one of the most used programming languages in the world, and for some pretty good reasons. First off, it's easy to learn. The syntax is super simple, almost writing in plain English. It's like reading a recipe you actually understand. You've followed it before. No complicated jargon. Put salt, put turmeric, and other ingredients, and you're done. You don't need to be a programming wizard just to get started. Python is versatile. You can use it for so many things like building websites, automating tasks, creating AI, doing data science, and much more. So if you need to build a website, Python got your back. You want to analyze the data, Python's right there. So it does it all. And here's the best part. Python has a massive community. Tons of people use it. So there are lots of tutorials, guides, and support out there. You got a problem? Someone has probably already solved it. So you're never alone in the Python world. It's like having a huge group of friends who speak all the same language. And it's super friendly to use. Think of Python like a smartphone of programming languages. Just like your phone lets you do everything, call in one go, text, check social media, watch endless cat videos. Yeah, Python lets you do pretty much anything you want in the coding world, which makes it super handy, right? Now, so you might be wondering, okay, it's good, Python is a nice language, but are there any actual uses? So where exactly is Python used in this real world? Python is usually used in industries like tech, data engineering, and recently AI. So whether it's automating data pipelines, cleaning up messy data, building machine learning models, or connecting different systems, Python is everywhere making it happen. Having a great tool like Python, it's just a part of an equation. You also need a place to use that tool. In layman terms, think of it like this. So you have all your content or data ready. Now you need a place to organize, track, and manage it all. And that's where IDEs comes in. IDE stands for Integrated Development Environment, and they're like a studio where all the magic happens. It's where your Python code comes to life. So what's an IDE or code editor? In the programming world, an IDE or a code editor is that organized, well run studio where all the behind the scenes happen. It's where you write your code and all your tools are ready to go. You just pick your tool, clean your code, catch mistakes, and you can just directly run your code how it works. So there are a lot of types of IDEs and editors that we use. Let's look at different studios where you can write your Python code for your Netflix like streaming service. And here are the best options. The first one is Jupyter Notebook. So Jupyter Notebook is like service, which is all about data science and interactive coding. And so Jupyter Notebook is your go-to studio. It's perfect for running and testing your code step by step. PyCharm is like a high-end production studio for Python developers. It's packed with serious coding, and its tools are designed to handle complex projects and make your coding experience and efficient. Coming to VS Code, it's like a flexible indie studio. It's lightweight and customizable, so you can set it up however you like, whether you're working on Python, SQL, or any other programming language. It's simple, but don't forget it's powerful. But the one that we're going to use today, the ultimate all-in-one studio package, Anaconda Navigator. It's like having everything you need in one place. Anaconda comes with Jupyter, so you don't have to install it separately. And it also comes with essential libraries that we're going to cover, like Pandas and Numpy in the coming sessions, and even a package manager to handle all your coding needs, making it super easy to manage your entire data pipeline. Okay, here's Anaconda brings to your coding library. So there are pre-installed data science libraries, which are essential ingredients when you're working with data. You have a package manager to handle all the dependencies. It's like having a smart shopping list that ensures you always have the right tools to get the job done. And obviously, the one that we're going to use, Jupyter Notebook, which is a tool that makes writing and testing code easy. So Anaconda is like having all things at one place. Okay, just to cover once again, and I would suggest those who don't have Anaconda or Jupyter Notebook to, because we're gonna do coding, so it's better when you practice with me. It would be a lot easier for you to understand Python. So just Google the first thing, Anaconda download. Okay, the first thing that when you do Anaconda download, you click on the first link that you get. The next thing you do, you see a page of distribution, see download. Ignore everything. Just focus on here. Skip registration. You skip the registration, scroll a little bit, go to Anaconda installers. So once you're on this page, choose the version that matches your operating system. So if you're using Windows, click on it. It's going to download and it's going to take like a minute or maybe more depending on your internet speed. Or if you have a Mac like me, you can download it based on your MacBook configurations. The one that I downloaded was this. If you have a Mac, make sure you download the graphic installer for simplicity. So after the download is complete, you just double click the file and follow the instructions. Click next. It's fairly simple and it would do everything for you. So for most of you, and I think all of you, the default options that Anaconda comes with are just fine. And just click hitting next until it's installed. So while it's installing, I'm gonna move on for now. So you have this notebook installed. Either you go in files and click on new notebook. This should work. Or you can go here, click on new and do Python code. It may be written as Python 3, Python 2.5, the version, but here in my system, it's Python like this, and you would have the screen. Okay. Once you open a new notebook, the screen changes and you're inside the Jupyter interface. And this is where all the magic will happen for today. And the main part of the screen will be a big blank area like this, and your cursor would be into the edit mode over here. This particular elongated rectangle thing is called a cell. A s- it's called a cell. A cell is where just you can type with me. If you can do multiple screens, Now screen cascading, where you can, just watch the video and side by side code. Just do it with me. It would be amazing. And we're gonna have fun with code. So a cell is where you code or probably text. Yeah, you can try typing in anything, your name, your favorite show, your favorite dialogue, anything you like. So now we have this here. But when I mentioned at the beginning, you can execute Python code in chunks one by one. You don't have to run all of it together. There are two types of cells. One is code and the other one is markdown. So in order to create a new cell, you click here or press escape and type and press B on your screen. It means it would add a cell below to the existing cell where your what cell was selected. So the default setting for a cell is it's a code cell. And this is where you're gonna write your Python code. This is one type of cell called code cell. If I unselect it again, press escape and press B again outside it, I would have another cell. And let's call it a markdown cell. It's where you write text, comments, or maybe format things. But in order to make this a markdown cell, you again click outside, press escape, and type M. And this would turn into a markdown cell. Let's say I made a mistake here. I shouldn't have done that. And now I need to, instead of deleting everything, I would like to delete this cell. I'm gonna click here. And do you see this icon over here? It's called delete or dustbin. I'm gonna click here and it's gonna get deleted. So for those who are not able to create a new cell, you can also click here. It would add a new cell over here. So I'm gonna do it again. Escape M, it's gonna be marked down. So right now we have tested three things. And in order to run this cell, I'm gonna type Shift plus Enter. And when I do Shift plus Enter, it's gonna look like this. I see some of you have previous experience with Java and HTML and other coding languages. I'm gonna show you a cool trick. It's not a Python coding, but it's a cool trick. So in order to add a cell below, you press B, and in order to cell above, you press A. This is cool. This is not the HTML part, but the HTML part is when I press A here, and I don't really like how, I'm running without a heading or we don't have a title. So what you can do here is, you see untitled here? Let's give our notebook a title, Python for data engineering, and I can rename it. Now I have a name for my notebook. The second thing I'm gonna do here is I'm gonna type Python for, let me do it capital, Python for data engineering. And I'm gonna turn it into Markdown. I'll Shift plus Enter. Now I have a code, but this doesn't look like a title. For those of you who are familiar with, or maybe not, I'm gonna tell you a cool trick. So this, if I do header one, this, if I type h1 with this less than and greater than sign, it's gonna turn into a heading. Cool, right? And there are different heading formats. I would like you guys to explore this by heading 2, which is like a little smaller than the previous one, heading 3, heading 4, like this. But I like heading 1. Now I want it to be in the I want it to be in the center of this. So I'm gonna type center, take this, paste it here, and this is at the center. Cool, right? So for those of you who are familiar with HTML, you can explore probably like, coloring it up, doing it in different formatting, make it bold, italic, underline it, a bunch of stuff that you can do. Okay, Python for data engineering, I'm gonna do again. So I have the cell here. I'm gonna add another cell A, B, or anywhere. Just give it a subheading. Let's say H3. I'm gonna give it a subheading. And say I'm gonna do day 1, right? I'm gonna convert it into Markdown by pressing Escape and M. And then I'm gonna press Shift and Enter. Day 1. Sounds cool? So let's say I pressed B a lot of times and I have some random text here, which I don't really want it here. So there are two ways, and it doesn't look nice, right? So I want to remove these lines. There are two ways to delete these two cells. The first one is, if you see on your right, you see a dustbin, which is like a trash can. You can you can click on it and the cell would be deleted. But if you want to use a shortcut, which is mentioned here, type DD. So if I delete it, it would be deleted. If I come back here on the other cell that I want to delete, I press escape and DD twice, it would be deleted. Make sense? Perfect. I think it's high time to move on to the next topic. Okay, just to cover basic things. To save the file, you can just click here and save notebook. It's going to be saved in a directory where you opened it from, like here, Python for data engineering, they want to have some samples. Uh, this is cool. We've, so it works like a regular programming. You type something or you thought you don't should have type, you press Control plus Z. You want to bring it again, just do Command plus Z. It's basic computer, like how you use your computer in day-to-day life. You can also run multiple codes, multiple lines at the same time. You just click on it, shift, select other cells, shift plus enter, you have run it. So since this is a text in a in a cell, so it wouldn't execute. It would give me an invalid syntax because this is not a code. This is a text. So I'm gonna reverse it. Okay, I'm gonna keep it as it is. Perfect. Amazing. So there's usually a question who is using Python for the first time. As you all can see, it's in a browser, and we all uh, relate browser with the internet. So the question is, can I use Jupyter without an internet connection? Absolutely. Once you have installed Anaconda, you don't need internet connection to use Jupyter Notebook. You only need the internet to install it and get your packages. That's it. So now that you have a good sense of Jupyter Notebook interface, you're ready to start writing and running Python code. You can experiment. You can type anything. You don't have to just replicate what I'm doing. Just do everything. You can write notes, mark down, see results instantly. It's like when you were a kid, you saw everything as a playground. Think of this Jupyter Notebook and Python as your playground. Write anything. What's the worst could happen? It could give you an error, right? But when it gives you an error, it gives you what the error is, and it says syntax error. You might not know. You might have not known what a syntax error is, and then you Google it, and then you learn more. So write anything you want. Do anything with this code. The worst thing that can happen, you get an error. The world is would the world would still revolve around sun. So it's gonna be fine. Ah, let's dive into the first Python code. And so this is a markdown cell, but there's another way you can write your code. Is it like when you type in £? Oh, it's not pound, it's hash. And it's a way to comment. Let's write your first Python code. So when I'm going to execute this cell, this line won't be executed because it has a hash before it. So it's like a comment before you're going to actually write your code. Let's start with something extremely simple like printing a message. And for this, we're going to use the print function. Congratulations, you're now stepping into the real world of printing. Now imagine it as your TV announcer. It lets Python speak out loud, broadcasting a message for all to hear. And let's make this something fun to kick things off. Print, hello, data engineering. So when I've written this code, and I'm going to execute it by pressing Shift plus Enter, let's see what happens. It printed me a message, or in the format, okay. Hello, data engineering world. It's like what you wrote, it's announced what you just wrote. Hello, data engineering world. So what just happened here? Let me break it down for you. Print, this is a built-in function in Python that displays text or data on the screen. It's like your Netflix subtitle generator that shows you the text on the screen while you watch it. And the string, this is called a string, a data type that we're going to cover in a coming session. It's just a bunch of characters like words or sentences wrapped in quotation mark. You can think of like anything like a script. It's like in layman terms, basically we're telling Python, hey, Python, hey friend, take this message and display it on the screen. Let's move on to the next topic, which is understanding variables. What are variables? For those who are confused, it's just a fancy word for a super simple concept. Think of a variable like a title, show title on Netflix. When you watch a series And you don't have to describe every episode of each time, right? You just say, hey, I'm watching Stranger Things, and everyone knows what you mean. So the title, Stranger Things, is like a variable in Python. It's the name that holds all the details inside. So you don't have to keep describing the show every time you talk about it. You just refer to it by its title. Oh, I'm watching Stranger Things. So in Python, see, it's similar. How you pick a name for your show and assign it a value, like the content of the show. And you use it by the equal to sign. Let me show you how it's done. I'm gonna write favorite. I'm gonna write it here. Favorite show equals to. So what I just did, I wrote a text Stranger Things and stored it in a variable called favorite show. So what I'm gonna do, I'm gonna print it now. I'm gonna announce it to the world. Oh, print, what do you wanna print? Print my favorite show. And when I'm gonna execute this, it's gonna tell me, oh, your favorite show is Stranger Things. So what just happened when you run it? The moment you execute it, Python will proudly announce Stranger Things. It's like Python just revealed the title of the show you're binge watching. And variable can hold anything. Variable can hold anything. It can hold a value. Let's say how many episodes are there in Stranger Things? Probably let's say a random number 8. Click here, then print episodes. It's gonna print me the number of episodes. Sounds cool, right? And it doesn't just stays with numbers and words. It can store sentences like show description. And if I just type it here, if I'm gonna do print, there you go. So if you had to describe stranger, this is probably what you say. Strange things. Let's see what it's gonna do. It would give you an syntax error. It would say invalid syntax. Perhaps you forgot a comma, right? But if I do this, if I put it under a string like this, you know how we did with Hello Data Engineering World? It would give me strange things. Make sense? How much words and a variable can store? Millions of articles in one variable. So Python, it depends on the memory that you have in your computer, in your laptop, in your system. So there's not a specific number, but it's a lot. Probably millions, billions. Depends on the system. If you're running a supercomputer, it can hold trillions. So every time we want to run SL, we have to run print. No, let's say print. If we have a show description here, I'm going to copy paste it here. So if I put it in a cell and I just shift plus enter, it would print me the same thing, but as a string. That how it is. So you have your preferred way. Either you just print. Print is like announcing what you do, and show descript. And if you just uh, execute the variable, it's gonna show you exact value in this. Perfect. Now, since we have stored sentences, but usually there's not only one show that we write or that we watch. There are a lot of shows we are binge watching, and somebody asks, "Oh, can you tell me your what are the shows? What are your favorite shows?" And I'm gonna do favorite shows. I'm gonna put it in a list. We're gonna cover this list concept in a while, but just so you know, what are your favorite show? Oh, I like Stranger Things, comma. I like The Office too, comma. I like Breaking Bad, and I also like Squid Game. So I'm gonna put it here, and when I'm gonna do print favorite shows, I'm gonna have this as an output. Oh, I like Stranger Things, all of this stuff. Make sense? Now, it's not a solid, it's not something that you cannot undo. Let's say you watch one show like a couple of years ago, but now there are new things that are coming in and you might like. So you can always change what you stored in a variable. So so now your favorite show has changed to, what do I think? What's a new show that might have changed that I really like? Okay, your new show has changed to Money Heist. And if I print it, favorite show. Initially it was Stranger Things, now Money Heist, so it has changed. So you can and it would take the whatever you assign last. So you can store values. You can always replace the value of a variable. What happens if I forget to assign a value? Like we have assigned favorite shows, everything. but we haven't assigned favorite movie. So when I run this cell, it's gonna give me an error. And it's gonna tell me exactly. It's a name error. We're gonna talk more about like the types of error in the coming session, but for now, it says name favorite movie is not defined. So we haven't assigned a value to it. So in technical terms, it would tell us name favorite movie is not assigned. So we can do it. So I'm gonna assign favorite movie. I'm gonna go with Inception. And if I print it, oh, I did movie. Yeah, I'm gonna do again favorite movie. And when I print it, it's gonna give me Inception now. The error is gone. So let's do a quick exercise. But before getting to the exercise, there are some rules. There are some rules for naming variables. The first rule is it must start with a letter, not a number. The second rule is can contain letters, numbers, and underscores. Third, can't use spaces. So usually we use underscore in place of spaces. And Python is a case sensitive language. When I say case sensitive, it means favorite show is different. Makes sense? So let's assign a value, my show. Let's say my show, and it could be anything. Try this on your end. Try this. You can write any show that you like. My recent favorite show was Physical 100 that I watched. It was amazing. Okay, I would show Physical 100. Um, so, all right, now that we know about variables, let's talk about what we can actually store in them. So in Python, data comes in different types, kind of like different kind of content on Netflix. And think about like when you open Netflix, you see all kind of shows, documentaries, comedy specials, action movies, and even some, weird reality TV shows that you cannot stop watching. I'm not judging. So each of these genres is different. You wouldn't treat an action movie like a documentary, and no one's is taking a comedy movie for an intellectual deep dive. So in the same way, Python has different data types. Each one behaves differently. Let's check some of them out. And now we're going to dive into understanding data types. Okay, there are a lot of data types. Start with the first one, which is numbers, or maybe I'd say integers. So int is a Python int. It is a whole number, and it includes negative number, but not fractions. So there's no limit how long a number can be. Python can pretty much handle everything. So let's say uh, some show had a somebody had a 5 episodes of the show, and if I do print episode, it would print me 5. Something had a rating of 4, and when I do print rating, it would print both. Let's say the runtime for a movie was 120 minutes, and I would print runtime. This is basically storing integer values into variables. Python is good for addition, basic arithmetic operations like result. Let's say 5 plus 3. What do you think the output would be? What a question I'm asking. 8. The output would be 8. Yeah. You can subtract. Let me just comment it out for better understanding. Addition, subtraction. Yeah. So I don't have to go into multiplication and division. So Python can do basic calculations, and for data engineering purposes, we do calculate some variables. Let's say somebody watched, there's a movie of 2.5 hours, so we have to convert it into minutes. So there are some formulas and mathematical operations that we have to use. So Python is used there to calculate arithmetic operations. The other one is the next one we're going to talk about float. Somebody who has experience with programming might know about these data types. So floats are used when numbers are decimal. So this is a real number with a floating point representation. And it is usually specified by a decimal point, like price of a movie could be 12.99, or the IMDb rating of a movie could be 8.7, and the runtime can be definitely in runtime can be in minutes 127.9. And if I print in a different way this time, let's say price, rating, and runtime. It would give me a print like this. And in the same way of calculating and using arithmetic operations, you can do the same with float. Now, moving on to the next data type, it's complex numbers. You might have studied them back in your school when you were learning imaginary numbers. I couldn't imagine what that was at. So a complex number is a number that consists of real and imaginary parts. This is usually used in physics and aeronautical science. I'm not sure. Yeah, let's say the movie score is 4 plus 3 and J. I can print this as it is, movie score 4 plus 3J. It can also do calculations 4 plus 6J. 4 plus 6J. That is it with complex numbers. And then something that we explored previously called strings. Strings are basically text that you write. And let's say your favorite movie changed to The Matrix. And the description of the movie is, so what I can do here is print, comma, prescription. So it's going to be the Matrix, a mind-bending action. So strings, how do you know if something's a string? So strings are usually enclosed in double quotes or single quotes. What if your strings have quotes inside it? You're quoting someone, but you have your string to have quotes inside it. What are you gonna do? So this would be said, I am the one. So use the other string that you haven't been using. So I'm gonna print quote, and there you go. You see how I used cleverly single quotes inside? That's how you do it. Okay, perfect. Coming to another data type, which is called Boolean. And Boolean is like yes or no, or it's in layman. So I'm speaking a lot of things in layman terms. It's like true and false. Oh, it's not Boolean. It's Boolean. Sorry. Now, let's say what's Boolean? It's like the play or pause buttons on your Netflix. So you have two options. Either you can play, it's true, or it's paused, false. Let's say if think about it like this: is the movie playing? Is the movie playing? And then it's true. And is the movie paused? Then it's false. So I'm gonna put here is playing as true, is paused as false, and then try printing is playing, comma is pause. And what I'm just gonna print an error because I made a name error. I did not assign it. I assigned it okay, but I did not use the right variable that I assigned. So I'm gonna change it to this one, copy, paste, have true, false. So since we have now covered Boolean, we're gonna move on to some complex data types now, like lists, tuples, and we're gonna cover conditions. We're gonna cover loops as of for now. Now we're gonna dive deeper into some uh, not so complex, but complex stuff than what we have done so far. And we're going to use all the concepts that we have covered, running a cell, all the data types, assigning a variable. So we're going to cover all of this. So there are a couple of there are a couple of, I would say, data types that are really important and are used very frequently in Python. And Python is kind of known for those data types too. Now we know how to store a variable, a couple of data types. We're going to cover a cool concept called lists. Imagine you walk into you open your Netflix account and you start adding shows to add to watch list and you want to watch them. You pick one show and then another and the other and the now you got a list of shows waiting for you to binge watch. But what actually happens in the back end? Let's cover them. Let's call it Netflix queue, and let's pick up some shows that we might like. Oh, I'm bored with Stranger Things now. Breaking Bad. The other show that people might like, Narcos, The Office, this, and I guess Friends is a little too popular, and other shows. So it's like adding shows to a list, plain English or basic language. List is list is something the name signifies, list. And if I'm gonna print the Netflix queue, it would print me the list. But here's the fun part. If you change your mind and maybe you decide, oh, I don't want Narcos, I want to replace it with something else like The Witcher. So what I'm gonna do, I'm gonna explore a cool, really cool concept here called indexing or indexes. Netflix queue, and I'm gonna count the position. In some of the buildings, there's ground floor, first floor, second floor, third floor, and goes on. The list goes on. So consider Narcos as the first floor, the office as second floor, and French as the third floor. What would you call a ground floor? What else can you call a ground floor in in your country apart from a ground floor? Or how would you represent a lobby or a ground floor by a number? The yeah. Let's say Narcos is the first floor. Then what would be Breaking Bad? We would call Netflix, this would be the 0th floor, and this would be the first floor. And I want to replace Narcos with some of the show. So I would fetch Narcos by doing square brackets and then typing 0. Oh, 0 is for Breaking Bad, sorry. Narcos would be 1. So I'm going to replace it with another show called The Witcher. So when I execute the same list again, Netflix queue, the Narcos would be replaced by The Witcher. Makes sense? So here are some, this is one of the common questions like what is a list? So a list is a built-in dynamic sized array. So we can store all types of items in this list. It may contain mixed of text, uh, numbers, and locations, phone numbers, anything. Lists can have duplicate items. Lists are mutable. When I say mutable, it means we can modify, replace, or delete the items. It's not like a hard and fixed rule. Once we have made the list and it's done, you can always, upgrade your list, change it, delete it, and you can do anything. Lists are usually ordered. You know how every show here has a index. 0, 1, 2, 3. So they are basically indexed. Lists are ordered. It maintains the order of elements based on how they are added. And the indexing for this, does this make sense? So a list is like a collection where you can store multiple items, like your watch list. So if you want to print something, here we modified it. But what if you just want to grab one show from your queue? How would you do it? You want to do print Netflix queue. Okay, let's say we want to fetch Breaking Bad. So I'm going to do 0. And since Python starts counting from 0, the first one would be Breaking Bad. Let's say there's a new show in the town. What if I need to add a new show to my queue? How do you add it? So there's a concept called append. In basic English, it's like putting something at the back of the already existing list, or putting it at the back of the queue. So simple coding, and you don't have to remember it at all, to be honest. It comes with the concept, or with the use case. So I don't remember append as in my memory. So when I have something, and let's say I have a real use case and I want to append the data, I want to add the data or merge it. I just simply refresh my memory. Oh, there's a function. There might be a function. And Google it. What's the function? And there it is. Append. Oh, append is something that I'm familiar with. I've read it before. I've learned it before. I go through documentation and it works fine. So and see, I'm gonna access the Netflix queue again, and I'm gonna write a function called append. There's a new show coming called Black Mirror. And if I just print the queue again, it adds Black Mirror at the end of my list. Moving on, let's say I added something. I watched The Witcher and now I want to remove it from the list. So what if you need to remove a show? There's a function for that. And I would say Netflix queue dot move Breaking Bad, maybe The Witcher, anything. And when I print it again to see what I have done so far, you see it has removed The Witcher from this location. Is there a built-in function available to add a new element in between? Yeah. So let's say you want to replace something. That's what we just did here. I can replace something. Netflix Q1, I replaced Narcos with The Witcher. So you can replace an element where you would have more understanding of how a loop goes through in it or how a function works. But now, uh, there's a similar concept related to list, but a new function or a data type. It's called tuples. Tuples. So tuples are basically similar to it's like a list, but the only difference is it cannot be changed once after it is created. Now, for example, if I create a Netflix playlist, and another difference is it starts and ends with a round bracket, whereas a list has a square bracket. So let me just put. Now we have a Netflix playlist. I print it, and I have the output like this. So to mention it in a nice way, yes, I can definitely give you examples. So tuple is immutable. That means you cannot change once it's entered. Tuples are similar to list, but unlike it, they cannot be changed after their creations. Tuples can hold elements of different data type. Right? Right now we have strings, but you can store numbers, boolean, sentences, anything. And the main characteristic of tuples are being ordered. So they have a order too. There you go. So for example, if I want to replace Breaking Bad with something else, let's say one, same example that we did. If I want to change Breaking Bad with The Witcher, it would give me an error. And it says it's a type error because I assigned something. It says tuple object does not support the item assignment. So if you try to replace an item, you Python will complain, oh, why are you doing this? Is not supposed to change. So why use tuples? Some data is meant to stay the same, like your permanent playlist, or you don't want to mess with something. You don't want to change or add or remove from a list of tables. That's where tuples are used. Um, yeah. Okay, I'll give you an example. Uh, have you seen on Netflix? There are a lot of movies and shows uh, that keep adding on every day. But the category option, action, sci-fi, uh, new category, or all those thrillers, all those categories remain always the same. It's always those 10 categories. And if somebody from a junior or somebody, a developer tries to, add a new category of their own uh, from Netflix backend, by mistake, they wouldn't be able to add it because it's a tuple. But whereas the list of movies is a list because uh, thriller can have multiple movies and the movies will keep on adding, but the thriller category would remain the same. That is something, a real life example that I can think of. Tuples. Does that make sense? Amazing. Let's move on to our third data type, which is set. Okay, tuples. Okay. Uh, if you understand lists, so tuples are basically the same thing. In lists, you can delete something, or you can add, remove, or modify something. While in tuples, once it's there, it's there. So also called tuples are immutable in that case. So for example, the example that I took of Netflix categories versus Netflix shows. Let's say we have action. It wouldn't change ever. Thriller. And we have movie 1, movie 2, here, movie 3, movie 4, and so on. So these movies can be added. So we can say uh, it's a list. It can change. There's an index, and yeah, movies can change. But uh, when it comes to action and thriller, it itself it's a tuple. It can be combined as like this, thriller, and it would never change. So once the tuple is created, it cannot be rechanged. Okay, perfect. Let's move on to our new data type, but I'm sure it can get confusing. It was confusing for me when I first learned it. All three concepts, list, tuples, and set, they all look similar, but with minor differences, and has a very specific use case when it comes to real life problems. Coming on to set, now imagine tuples can have duplicate values. I can add Stranger Things multiple times, but I cannot change that. But while set, the only condition or only parameter that makes set different from lists and tuples is that it cannot have duplicate values. For example, it's like imagine Netflix keeping a registry of shows they have available. Like if they have 10 copies of Friends, they just write Friends once. And that's exactly how sets work. So when you search for Friends, you would see only one Friends uh, show. You won't see 10 appearances of that. So that's where sets come in. And the only difference is it automatically removes duplicates. Even if you try to add it, it would remove it. I will give you an example. The another difference between list, tuples, and set is it is used in curly brackets. Yeah, as you can see, I have the office sets here. And if I just try to print try to print it, it would only show me one occurrence of the office, which means it removes the duplicate occurrences automatically by itself. Sets are mutable. That means you can change the variable, you can change the position of the text. It's unindexed, which means you cannot directly point to one, like we pointed out to in list. We did indexing 0 and we pointed out to the breaking bed directly. In sets, we cannot do that. It's unindexed and do not contain duplicates. So the order of these elements is not preserved. Every time I run it, it would have a different, and it can change. So let's say, but I can add something. Let's say if I want to add a show called Squid Game, I can add it. So Squid Game is added at the end. So you can use the add function to insert a new item into the set. You can also remove them. So let's say if you want to remove it, you can remove it. So now in the updated list, you have removed friends. Can be a little confusing, but as we move on and explore different applications of these data types, we would have more understanding. It can seem confusing in the first go, but so let's say if there are the offices and when you run it, it would only show one office. It wouldn't show what position is it at, or um, and the position wouldn't matter and it wouldn't store itself. It's just come with this application where we would have uh, unique values. Okay, let's now talk about dictionaries. Think of it like a profile. When you log in, you see a pop-up, you see a screen that, oh, who is logging in? Is it user A, B, or C? Think of it like the user profile. And each user has a name, age, and their preferred genre. So instead of listing all the data, we organize it into key and value pairs. How do we do that? Let me give you an example. Let's create a Netflix profile. So it is stored in curly brackets, and there would be a key and value pair. I'll give you an example. Let's say the name. Let's take the name as Alex, comma, We have the age, let's say 28. Age would be an integer type, let's say preferred genre, let's say sci-fi. So this is the most basic structure of a dictionary. When I print it, I'll show you some cool examples around it. When I print it, I would get the exact same print. And this is like a print statement or storing some random data type into a variable and just printing it. But there are some cool usages. So in technical terms, a dictionary stores data as key value pairs. This would be the key here, and this is the value in it, like a user profile with name, age, and genre. So instead of guessing the age or something or other parameter from a message list, we can directly access this piece of information uh, through this dictionary. For example, let's say I have a lot of dictionary. This is one of the most simplest example. Can anybody guess? And this is the data that I don't have, really visibility over. But and there are millions of records like this. There are millions of users with different age, different preferred genre, but I'm specifically interested in knowing the age of Alex. How do I do that? So I would say, um, or maybe the preferred genre, age would be too creepy. Want to know Alex's favorite genre? I would print it like this. Netflix user profile. Okay. What happens when I click it? What could be the output be? Since Netflix user profile only has one dictionary in it, one guy named Alex, age 28, preferred genre, it will show me the answer is sci-fi. So using this key, we can quickly fetch the value that what we are specifically interested in. Let's say Alex's birthday is coming up and we want to update his age. So how do we update the age? The simplest form is age 29, like you do in a list. And if I just print it out, print the new dictionary, it would have age 29 instead of age 28. So you can change them. So what does this prove us? This tells us that dictionary are mutable. Make sense? And let's say if we get a new show and we have genre, age, and name, uh, so how do we add a new key value pair in it? Let me give you an example. Netflix user profile, favorite show, and I would say Alice in Borderland. And now if I print the dictionary again, what would it show me? It would show me Alex's name, age, preferred genre, and a new key value pair, which is favorite show and the name of the show. So this proves us, you can add a new key value pair. I'll explore a few things in dictionaries. Venkat has asked a good question. For one record, we can update age and name. But what if we have multiple records then? How can you add a new value pair in between dictionary? It wouldn't matter like where you're adding it because you won't you're accessing this key value pair by the key, name, age, preferred genre. So I cannot do 0 here and then do something. So I would have to point out to this key. So it wouldn't matter. Let's dive into some complex examples and real life use cases. So So think of this catalog as where each user has a profile, has specific details about their habits, where a dictionary allows you to access and modify all of this information quickly. Let's dive into a little deeper into dictionaries. So let's say we have a dictionary called users, where we have the same thing. So this is a concept of dictionary in a dictionary. So here's a user. So keys are like labels. We have Alex, Jordan, Taylor, and they contain, and the values are the information stored under those labels. It can be anything. It could have been a list, it could have been a dictionary, it could have been a set or a tuple. So let's say if now this is a more complex data getting into real world, uh, and my manager asked me, or somebody asked me, oh, I want to know Alex's favorite show, or maybe Taylor's favorite show. How would I access it? Right now, we just only have 3 records, where it could be millions. But when we know what we are looking into, it would be really easier to find through dictionaries. So what I'm going to do, I'm going to print users, Taylor, and I can type here what their favorite show is. Favorite show. And if I execute it, it would show me the exact show they are watching. You know how granular we are going in a record of 3 with 3 keys. You can just point to the exact value from the key that you're looking into. You just need to know where you want to look at. So uh what's the order of this? So we mentioned Taylor, favorite show, brackets, everything. So what this code does here, it first access Taylor. Oh, we have a user called Taylor. It looks for it. If there's no Taylor, it would give you an error. And then it when goes to favorite show here, and then it finds this Breaking Bad and presents it to here. So that's how you can go deeper into dictionaries and extract what exactly you want. Let me give you another example. So let's say Taylor wants, no, I don't like the Breaking Bad. I want to change it to something else. So you can always modify a dictionary. How would you do that? You would follow the same analogy, Taylor and favorite show, and you can update it with whatever you want. Let's say prom. Prom is a show. Thriller show. So if I just want to print Taylor's favorite show now, copy paste, what will it show me? Can anybody guess what would be the output would be for this one? Will it give me an error? From exactly. It's a name error. Name of what? The variable that we assigned. Users. While we are using here, a user. But it did not give me error in print statement. It executed this statement first. It is pointing out user. Oh, it doesn't exist at all. What are you trying to change? When I click here, it would give me from initial. And if I have initially it gave me Breaking Bad because it was Breaking Bad here. Now it's giving me. So uh, this is a core topic of data engineering when you want to go inside the data when you have trillions of uh, transactions, or it could be any kind of data, and you want to change one few specific things, and you have a pipeline in hand. It could also help you in organizing your data, flowing it through a pipeline. Now, how do you add new items? Adding new items. So now we have 3 keys, which is defined by, name. Can I query who are the users watching Breaking Bad? From this dictionary, maybe, maybe not, because it's a reverse thing. But if you can come up with a logic by creating your own function, yes, you can. Coming back to adding new items, let's say now we have users Alex, Jordan, and Taylor. There's a new user who just signed up with us. Let's call him user Sam, and let's assign a dictionary to it. The age of Sam would be 25. His favorite genre would be let's say horror, and their favorite show would be, and if I just I made the same mistake again, it's users. And if I just print users, Sam, it would give me this list. There's the dictionary that we just created. We can dive deeper, like what's their favorite genre and so on. Pretty much everything we can do. Now, unlike tuples or some not tuples, sorry, uh, we can also delete uh, items. Let's say I mistakenly did horror and I want to delete it, or there's a user that has ended the subscription with us, and now I don't want give them the access anymore, so I can delete that user. Let's say, and the command would be for that delete users. The user that I want to delete is Jordan. Jordan decided to switch to Prime Videos, unfortunately, so we have to revoke the access. So now when I print users, I wouldn't have Jordan. I would have Alex, I would have Taylor, and I would have Sam. Can we add a user that has only age and favorite genre and no favorite show? Yes, you can. You can try. You can add a null value. You can add a missing value over there. You can add a blank space. Definitely. Why do we use dictionaries? Dictionaries are basically the amazing, fantastic way when you need to store data that is related to each other. For example, when you are organizing the details, like we just did, each show might have something like a title, a genre, a release year. So instead of keeping a list of all shows and guessing which detail belongs to which, you use a dictionary to store this information in a structured way. So it's usually fast and organized. Now there's a question. Can dictionaries be numbers? Let's explore this. Can dictionaries be numbers? Yes. Let's create a dictionary called show ratings and do this. There you go. Can dictionaries have duplicate keys? No. A dictionary cannot have duplicate keys. And if you try to add the same key again, it will simply override the previous value. So can dictionary values be list? Absolutely. You can add a list here and then access it and point to the exact location. List would act in the same way as it would act as an independent list, but you can definitely use the concept of indexing and point out to the exact value or index that you want to. How do I check if a key exists in dictionary? Okay, perfect. So how do I check if a key exists in Netflix stores? So I'm gonna introduce you to a fun concept. If Stranger Things. Okay, I'm gonna avoid this for now. There are ways to check. You can run a loop. You can type in if and else statement that and conditions that we're gonna cover in the next section. So I'm gonna wrap dictionaries here because we have a lot of other concepts to cover. Do type. Let's say we know 42 is an integer, but how do we know? Just do type and it shows you it's an integer. Guessing data types. If you want it to be a float, like 3.14, it would give you the data type. There's another one, cool trick. If you wanted to type, make it a list quickly, Stranger Things, Breaking Bad, it would tell you it's a list. Sounds cool. There's another cool thing that I've been doing throughout. You may not have noticed. So let's say if I want to write this show rating, one way is to I copy here. The first way is I write the full name of it. That takes time. Nobody has time. The second way is I can directly copy paste. This also takes time. But the third thing that I can write show and press tab. It would show me all the variables I've created so far. I would just select the one that I need and enter. Let's say I want to use append function, but I don't know what append does. I don't know how to append or what this term means. So I'm going to do a question mark in front of it and run this cell. It would give me the definition, which is append object to the end of the list. How to enable auto hint or suggestion in the notebook. Um, I there's an AI that works with Jupyter Notebook. I'm not sure what version it is, but that can be helpful. Should be somewhere here. I disabled it so that I can be more hands-on, but there's an AI that can help you with it. So append, or there are a lot of things that you can do. If you just do append function, question mark would do the trick for you. The second is help. If you want to know what this function would do, you can do this. It would show you the same thing but in a different way. Help on built-in function append, method of built-ins, and the definition append object at the end of the list. So these two features pretty often, and it would definitely help you in being a better programmer. Also, random question: what if I just type this? It will give you an error because type takes an argument. So don't be afraid when you see an error. It's usually coming out of the code that you wrote, and if it's an error, it can be fixed too. So just keep calm and just figure out where this error is coming from. Moving on to the next topic, just brace yourself. We're going to use the concepts that we have learned so far, and yeah, now we are diving into conditional statements. So Uh, conditional statements are basically the rules that make our program think and make decisions. It's just when you're deciding what to watch on Netflix and you look at the title, genre, and sometimes mood to decide if you're in the mood for a thriller or a comedy. So Python would do the same thing when we need to make a choice in our code. Let's start simple. Let's start with the basics. You got a condition, something you check to see if it's true or false. Imagine you wake up in the morning, it's a Saturday, and ask yourself, oh, what's the weather like today? Or you want to watch a movie based on how the weather is. Let's say, let's assign a variable called weather. And let's see if the weather is sunny. The weather is today sunny. So you have written a code for yourself. If weather is sunny, uh, you want to watch a comedy. However, if the weather is not sunny or anything else, you're like, maybe a cozy drama, and you just run it. Since the weather was sunny, so how it works in the loop, the Python is asking, oh, is it sunny? Yes. It tells you to watch a comedy, something light and fun. And if it's not sunny or any other, whether it's cloudy, rainy, or snowing, it'll suggest a drama instead. This is the magic of if-else statement. The program checks the condition, and based on whether it's true or not, it executes a specific block of code. Moving on, there is an elif condition that we're going to cover. Let's say I want to see, I don't, if it's sunny, okay, I'm good with watching a comedy. But if it's rainy, I want to watch a mystery movie. So how would I do it? I'm going to write the same thing. Uh, let's say, let's say today the weather is rainy. If weather, I'm going to write the same code. Sunny, print, watch a comedy. However, elif, it's called else if combined into elif. If the weather is rainy, then print, or like if it's something else, uh, I'll stick to drama. So how it's gonna work, since the weather is rainy, It's gonna go in this first condition and it won't care. Oh, if the weather is rainy, no, it's sunny. It's gonna skip out of this. It won't print watch a comedy. It's gonna come to the next statement. And oh, if is the weather rainy? Oh yes, it's gonna execute this statement and come straight out of the if else condition. It won't execute else condition. Gonna watch a mystery. So what if I have a more complex condition? And now instead of, let me just copy paste it here, complex condition. Let me paste it here. Now I want to know, oh, what's the day of the week? My preference of movies changes based on what day is it. Like on a weekend, I'm mood in something else mood. If it's night, it's different mood. If it's a weekday, it's a different mood. So let's say it's day of the week is Saturday. And I would like to add a condition. Let me write this code again for you. If weather equals to sunny and day of, sorry, day of the week is Saturday, I'll print, I won't stay home. I'd like to go to the beach. However, elif weather equals to sunny and day the week is Monday, print time to work, you adult. And if it's nothing, maybe stay indoor if it's any other day. So let me change to sunny. Can anybody tell me what the output of this code would be? Let me run it. So we have a variable called weather where and it's sunny. The day of the week is Saturday. And it's gonna check if the weather is sunny and day of the week is Saturday, go to the beach. So we are using the AND operator here. It's called an operator to check two conditions at once. So if it's sunny on Saturday, you're off the beach. If it's sunny on Monday, you go to work. But if it's none of these, don't worry. Like you will stay indoor and Netflix will do the rest. So the question is, can I use multiple conditions? Yes, absolutely. You can use as many conditions as you want. Like, we've used day of the week weather. You can use and month. If it's January, it's February, time of the day. You can use mood of the day. You can use as many conditions as you want. What happens if none of the conditions are true? If none of the conditions meet the criteria, if or elif statements are not true, the program will execute this last block of else and it would print maybe stay indoor. Let's say now we're gonna integrate one concept from today's session, right? And let's say there's pasta and pizza in the fridge. I can run a loop if pizza in fridge print pizza in the fridge. I can use another if condition. If pasta in fridge print pasta in the fridge. So it would print both the statements. Since both of them are true, it would print pizza and pasta both in the fridge. So to wrap it up, if-else statements in Python are like decisions we make every day. They help Python decide what to do next based on different conditions, whether it's deciding what to wear, what to eat, or whether you should watch a comedy or thriller. Python helps you make those decisions based on simple rules. Loops are basically used to automate repetitive tasks. So if you've ever done a repetitive task, you know how exhausting it can get, right? It's like when you binge watch Netflix and you're clicking next episode over and over again. But imagine if you had to manually click up the button every time. It's exhausting, right? So well, Python has loops that can automate those repetitive tasks for you. Just like when Netflix autoplays the next episode for you, Python can do the same for your code. And it's probably built on the same logic on Netflix side. So let's start with the for loop. Let's start with for loop. So here's what the code looks like. For episode in range 1 to 6, print play episode. You might be wondering, oh, this seems like a crazy code to advanced concept. Let me walk you through, don't worry. Uh, Here, the, the first thing that you see here is F. We haven't used it before, we just directly print it, right? So the F string here is the easiest way to print in Python. So it's also came from a popular concept back then called format. So if you want to include a variable like this, something else out of a normal string, you would use F before double quotes, and it would format it on the basis. The second thing that you might be wondering is, oh, what's episode? So it's like an iteration that it's gonna do, and the iteration is gonna go through this function called a range. Range means we start counting from 1 and stop just before 6, giving us episodes 1 through 5. So the loop runs through each number. For example, for episode in range 1, so it's going to start with 1. This is the first output of the and print f play episode. In these curly bracket, it's going to put 1 because episode stores one value of the show. It's going to come again back to this. Now the range is 2. The function range automatically incremented by 1. And now the episode is 2. The condition is true. Play episode 2 of the show and goes on till 5. And when it's 5 and it does 6, it checks, oh, it shows 1 to 6, but it just stops right before that. So it displays the output of play episode 5 of the show. And when I press shift and enter, it's going to run it for me. So it's going to play all the episodes for me. So the explanation here is the range function means we start counting from 1 and stop just before 6, giving us episodes 1 through 5. And the loop runs through each number like 1, 2, 3, 4, 5, and executes the code each time, just like Netflix handles your episode marathon without a pause. But sometimes there are amazing series that you want to binge watch and you don't want to stop until the season is over. We've all been through this. In that case, we use while loop, until the series is over. Imagine you're watching something and you don't know, sometimes you don't know exactly how many episodes you'll need to finish before you run out of episodes. But you're going to watch as long as there are episodes left. And that's what we're going to do now. Let's say you have a list, episodes left equal to 5. There are a total of 5 episodes. While you don't care, so you're going to do while episodes left is greater than 0. You don't want it to stop. So print play an episode. And since we have watched one episode, what we're going to do, we're going to minus the episode that we have just watched. Okay, let me see where the error is coming from. Since we haven't, yeah, so it looks like it's still running. Need to stop it. And I can go here. If you run into some infinite loops and you're not able to run it, you can just go back to your file manager and you have this play and pause button. This is stop button. You can just stop it from here and then run it again. Let's take a real life example. Uh, let's take a real life example here. Let's say you've got a watch list and or maybe a to-do list for the day for a Sunday, and you want to check off everything on your list. So instead of manually writing out a print statement for each task, you can loop through your list. You can create a list of tasks, and Python will take care of the rest. And here's how to do it. Let's say you have a to-do list for your Sunday, and the list somehow looks like this. Watch Netflix, maybe clean the house, and make popcorn, and then lastly, probably take a nap. What's the semicolon at the end of the line? The colon. This one. So semicolon is basically used to end an if or while or a for loop statement. That's how the Python syntax works. Uh, Pratiksha is asking for range. The increment value we're not giving. So by default, it's taking one. But what if we need to increment by two? We do not have to use the range then. That's a that's an amazing question. So there are options that you can explore. Uh, there are iterations that we can do. We're gonna do today like how to skip one iteration or how to increment range by two or three. You can put any numbers. We're gonna explore them today. But yes, for to answer your questions, yes, we can use the same range function if you wanna increment by another number. But in this real life example, if we have a to-do list that we wanna follow, I can simply run a loop in a list like for task in to-do list. So instead of going into a range this time, this is my range. And instead of typing range or any number, I can just type in the name of the list here. And I'm gonna put a semicolon and print out the statement task, task. I'm gonna mark as done. Let's say this gives me the output. So the task one, watch Netflix, done. Task two, clean the house, done. Make popcorn, done. Take a nap, done. Are you all able to run this code? I would like to know what's your approach. Are you coding side by side while I'm coding, or you want me to give you a couple of seconds to write the code and then run it on your end? What do you guys prefer? Oh, okay. From now, because we're going to dive into some more complex coding than yesterday. Yesterday was like basics. Today, I would like you to code side by side. It would give you more confidence when you'll run it, and it would be more interesting, definitely, for you. Watching me, you'd forget everything, even the concepts. But while you were doing it with you'll see some errors, and that's where you'll start learning, actually. This is fairly simple. We created a list as we discussed yesterday, the concept of list. List has indexes like 0, 1, 2, 3. So it would go inside the list, take the first iteration as watch Netflix, and print this task done. The second thing it's going to do, it's going to go into another iteration, but now here, clean the house, done. It's going to go into another iteration called make popcorn, done. And it's going to go last iteration, take nap, done. So when it's going to go into next one, there's nothing. So the loop would stop executing. So in the last line of code here, we're using a print statement. It's like speaking out loud, but in the coding language. The first thing that I've mentioned here is F, which is also known as the uh, format function. It was back then dot format something, but since Python is evolving, it's people prefer writing F instead. Then we have everything that we want to print under double quotes. The test that we want to print is task done, but we want it to be dynamic. So instead of for making it into a dynamic code, we're gonna put whatever iteration, or it's going into the list and put it here under curly brackets. So whenever we are going into an iteration of this list, it's going to print the list item in here. So like watch Netflix is coming from this curly brackets. Does that make sense? Okay. I think some of you are getting a grasp of it. Uh, to get into this further, we have a couple of questions like, can I break out of a loop? If I want to run a loop, but I want it to stop at some point, and I don't want it to run to the fullest. I want it to, when it meets the requirement, I want it to stop. So the answer is, of course, sometimes you might want to stop and the loop before it finishes all the tasks. Like, imagine you're watching a Netflix show and midway through the season, you get a text, hey, it's time to go, or somebody is calling you. So you leave the show and stop watching. In Python, you can use break statements to stop the loop. I'll give you a quick example. Let's say the range goes from 1 to 100. So I'm going to do if I 5 print, and when you'll use break command here, it's going to stop the loop when it reaches 5. So it's going to go into 1, do nothing, 2, nothing, 3, nothing, 4, nothing. When it comes to 5, it's gonna go into this loop. Since there is no else condition, it would definitely do nothing. And if when it meets this condition, if I equals to 5, it's gonna print I'm done watching today and exiting the loop. And uh, when it moves on to the next statement break, it breaks out of the loop and stops it right there. Now, what if I want to skip one iteration? So there's a way to skip one iteration. I'm gonna take the same example for I in range. I'm going to use a command called continue this time. What it does, it skips episode 3. And I'm going to print. Does that make sense? Rainer is asking, when do we use equal to, double equal to? We use it, equal to is basically, the one equal to is basically used to assign a variable. We have seen this. We are assigning a list to a variable called to-do list. Double equal to is in the coding language is usually used to compare whether I is equal to 3. It's not storing, it's comparing. So that's when we use double equal to. So in this case, what's happening? Are you able to code this line of code? Let me know. This is pretty interesting. So it's how the iteration will go for this. For I in range 1 to 6, it's going to take 1 initially, and then it will test this condition. It's false. It would come out of the loop and it would print episode 1. It'll go into range 2, print episode 2. When it goes into this condition 3 and it's true, it doesn't do anything. It just continues and skips episode 3 and it won't print anything. So the next iteration when it goes into 4, this condition is not true again and it's going to print episode 4. And lastly, when it goes into 5, it's going to print, since this condition is not again true, it's going to print episode 5. Are you able to get this output? Episode 1, 2, 4, and 5. Somebody is asking a question. How this will be used in data engineering? You may use this exact line of code in data engineering. You may not. That's the point of the These Today course is to get accustomed with the concepts and to tell you the power of Python, what you can do. What you do in data engineering would depend on a specific type of problems. For example, where I work currently, it's one of the biggest insurance company, and we have a huge data pipeline that that I've built over the past 2 years. and I follow. Do I use loops? Yes, I use loop. Do I use this exact line of code? Probably. No, I don't think so. But do I use the concept of looping? Yes. Do I use the concept conditions like if else? Yes. Do I use while loop? Yes. Do I use thousands other things that we have learned yesterday? Maybe, maybe not. It would depend on specific situation. But when you know, oh, there's a concept that exists, there's a condition that you can use, there's a loop that you can run, you can do anything. There's a infinite possibility that you can build. So data engineering, you will most likely in most of the jobs that I have seen, we use loops on daily basis. Amazing. I see some thumbs up. That is amazing. Now I'm going to dive into a cooler concept, which is functions. I really like to automate things. So when you have to calculate manually, it's really, you don't drive me off. But when I get to automate something, it's amazing. I'm going to dive deeper into a thing called functions now. So why, like imagine you had a long day and all you want to do is relax and watch something on Netflix. But instead of scrolling endlessly, Netflix knows what exactly you want to watch. You click a button, boom, it recommends a perfect movie for you. So what's happening behind the scenes? The thing that's happening behind the scenes is functions. In Python, a function is like a recommendation system or something, a function that you can build on your own. And you can, there's infinite possibility that you can make a function out of. So let's create a function. Before diving into it, let me familiarize you with one concept that you already know. It's called if else. So I'm gonna write a code. You can type it with me because you probably already know about it. I'm gonna use if else condition here. Let's say we are interested in genre action. So if genre is action, print. I wanna watch. How about Mad Max Fury? It's like a recommendation engine. Well, if the genre is comedy, what do I want to do? If the genre is drama, or if the condition doesn't match anything, yes, it's a name error. Assign value exactly, and because I use double equal to here, it is trying to compare instead of assigning action to genre variable. That is amazing. You guys are great. So when I remove that equal to sign, right now. So it's the same thing that you want to do, and you remove that double equal to sign. So what it's going to do here is, since we have stored genre action here, and if genre is action, the first condition is true. So it is directly going to print that and exit out of these loops. Now, since we have already defined genre action, I don't want to do this again and again. Can we? I always try to figure out how can I make it dynamic. And I usually, in my day-to-day job, I usually try to find out how can I automate things or how can I save my time because saving time is the most important thing. That's why we run for memory, optimizing code, and uh, bringing the code shorter and shorter. So there's a way to optimize this code if I can dynamically change genre. So that's where the function comes in. So I'm going to copy paste the same thing here. So the question is, let's say I want to, I have genre here and genre is action, but I don't want to give action or drama again and again. I would like to call the function. I would like to create a function. In that case, I would write a statement called def, which you could make anything. It's the syntax, maybe define or anything. Defined function called recommend movie. And I'm going to take a parameter as genre, create a function. So now I've created a function. I can, here I had only one movie called action. But when I created this function dynamic, I can probably send anything that I want to. So here's what happened in these two lines of code. We're defining a function. which is like setting up a recommending movie. This parameter, this is the name of your this is basically the name of your function. It takes the movie genre as a parameter. Just like you tell your Netflix what type of movie you want. So here you tell Python the genre here. And inside the function, based on the genre you give it, Python gives a movie suggestion. You want to see an example? Let's do it. Calling the function. How do we call the function? We're going to take this function and instead of just typing anything, we're going to type what genre we want. Let's say this time we want to watch comedy. So I'm going to put comedy here. And when I run it, it's going to suggest what it's going to do. It's going to call this function. It's going to go here. And instead of genre, it would replace it as comedy. The loop will run. It will check if genre is comedy. No. Here. Sorry, if genre is action. No. It will go into the next condition. If genre is comedy, yes. And it would take the output from here and print it for you and exit the loop. Does that make sense? So in this case, what you need to do, you're gonna take this and try running this code. So when you look at when you look away and look at the text, it has changed. It seems a lot complicated. But if you follow through every word that I'm saying, it would make a lot of sense to you. Does it make sense? Are you able to run the code? So now this was a simple function. We'll dive into a more, sure. I have 24 participants today. So I'm expecting thumbs ups, yeah, today. Let me know if my pace is okay, if I'm going too fast, too slow. I see a lot of you are able to run the code. Let's make this a little more interesting. So how do you add parameters, more parameter? The function we created is with one parameter. Genre is called a parameter and we have one parameter here is now functions with multiple parameter. Is anybody else facing the same problem? Python libraries. So Python is usually popular because of its libraries, because we have a set of codes that are readily available for us to use. Now, I would give you an example. What are Python libraries and why is it useful? Imagine you just move into a new apartment and you need to set up a kitchen. You have two choices. Option one, buy raw ingredients for your kitchen, spices, pans, knives, and a lot of other things. The other option you have is you have a meal kit. Get a meal kit that comes with pre-measured ingredients, spices, recipe card. All you have to do is follow the steps and just run it. Which one sounds easier to you guys? Option one or option two? These meal kits are for programming. Instead of writing everything from scratch, you can use a pre-written code called as functions, modules, or tools to get things done faster. You want to work with numbers? There's a library for that. You want to manipulate text? There's a library for that. You want to do machine learning? There's a library for that. You want to build a chatbot? There's a library for that. So let's say we're building Netflix, and Netflix deals with huge amount of data, like what people are watching, how long do they watch, what genres they like, and so on. So imagine if Netflix engineers had to write every single function from scratch, like handling data, visualizing trends, or making recommendations. It would take forever to build even a small program or a function. So instead, they use Python libraries to make the job easier, which has pre-written codes and functions in it. And I believe that is the more efficient way. Built-in libraries. And the second is external libraries. Built-in libraries comes with Python automatically, like a math function, a date time, a random function, and some of the functions that we have used. External libraries are they need to be installed separately. So built-in libraries are like I am guessing everybody uses a smartphone or know what a smartphone is. So when you buy a smartphone, default or built-in libraries are like default apps on your phone, like a calculator, a calendar, a clock, while external libraries are like the apps you download from App Store, like Instagram, Facebook, Spotify. Make sense? Now let's break down a few essential libraries that are super important for data engineering. But before, let's explore some built-in libraries and some functions, the basics. For example, how do you import a library? You type import random. So what this library does, you can always Google what a library does or how to do it, but what this one does, it just generates a random number for you. You might have used this function in Excel, Java, or other coding languages, or probably everybody knows what a random number is. How it works, let's say I have a list of movies that I want to watch. Or none of them are movies, they are shows actually. But just to get into the concept, and if I just print a random choice of movies, it would it would randomly choose a movie from this list, and print the output for me. Make sense? And you might be wondering, oh, random, why and where do we use this function? Have you ever created a playlist on Spotify, YouTube, or any music app, and you have been listening to songs in one order all the time? And today, oh, I like the playlist, but I don't like the order. Surprise me. And that's when you click on your shuffle play button. And that's exactly how it works. It picks a movie or a song for you to at random. But since I've mentioned that, oh, libraries are external libraries and they need to be installed separately, but how do we install them? So every library might have a different way of installing. Every uh, IDE and platform might have a different way of installing a library, but the most general way is to install a library is using these commands like pip install, and you type the library name. So pip is usually known as the Python manager. It's like an app store for Python. So you can install any external library by using this command. Today we're going to use two main libraries, which is Numpy and Pandas. So in Jupyter Notebook, as we discussed yesterday, most of the libraries are already installed for you to get started. But if it's not there in somebody's laptop, I would write the command to install pip install. Make sure to use this exclamation mark before you execute the command. Pip install numpy. And when you do shift and enter, it's going to install the application library for you. So in my case, it says requirement already satisfied since I already have this. But if you don't, it's going to run a few commands for you and install it. The second library that we're going to install today, pip install pandas. And when I click on this, it says requirement already satisfied. If you have Jupyter Notebook, that is being coming from Anaconda, you might have already these libraries, but let me just still. Okay, moving on. So let's dive deeper into this library called NumPy. So NumPy basically stands for numerical Python, since as the name suggests, like mostly used around numbers. And it's usually the backbone of data engineering because you might have to do a lot of calculations. It makes working with numbers super fast. Like imagine you are tracking how many hours you binge watch Netflix each day. Without NumPy, if you wanted to find the average, you'd have to type it something like this. Oh, every day you're watching, let's say someday you watch for 2 hours, three, then five, then six, then eight. and then again 1. So in order to calculate the average of it, that we can do some calculations. So you have to write it like this. You have to take the sum of hours from this list, and length function calculates the number of elements in a list. So length of hours and then print average 4.16666. This is how you have to do it without Python. Then if you want to use NumPy, so the first thing that you have to do is import the library. The, what we did here is we installed the libraries, but here you first have to import it. And in the whole Python program, no, a Jupyter notebook, in one Jupyter, you have to import the library only once. Once you import it, it's done. So import, this is a one-time statement that we're going to write, import numpy as np. What it does mean, it's importing the library numpy as means, oh, I want to give it a name or something. I don't want to write numpy every time I want to refer to this library. I have a shorter form which is called np, and a lot of data engineers, almost all the data engineers has accepted this term as kind of like everybody is using it. So np, what I'm going to do, I'm going to do hours np dot array. So array is a collection of items in a list. Again, the same thing. I'm gonna create an array of the same numbers, and I'm gonna print like the np dot mean. So np has a function in itself called mean. So we don't have to calculate the average by calculating, like, giving the exact formula. It has a formula in itself, and what it's gonna do, it well, it's gonna find the average. You see, instead of writing 3 lines, I have the data coming from 2 lines. So that saved us 1 line of code. So this is the simplest example that I could build. NumPy also helps in handling huge data sets efficiently, which is exactly how Netflix uses to analyze user behavior. Now let's play around with some of the libraries, some of the function. Like, okay, this is a list. Now, let's say you want to generate special numbers and you don't want to type. Let's say you have a list, or you want to have type zeros and indefinite zeros. Let's say I can create NP, I can write NP. By writing NP, I can refer to the NumPy library. Let me simplify it for you. Generating an array of zeros. And if I just write np dot zeros, how many zeros do we want? We have 26 participants in this class. Let's say 26. And if I just print it, I have 26 sets of zeros. If I want to type once, p dot once, are you able to code it along by my side? Because this is a simple code. Okay, yeah. We also explored one concept yesterday about tab. So if I do np dot and press tab, it would give me a plethora of list of functions that I can use in NumPy. You see, a lot of functions that you can use like this. So you can explore. And the other thing that you can explore is writing a question mark beside this and to see what the number does. So it returns a new array of given shape and type filled with ones. So let's say you're exploring functions and you don't know what it's doing. You can do add. I'm giving an example and you want to explore this function, what it does, put a question mark and do this. So what it does, it add arguments element wise. So whatever you have in your array, it adds. Make sense? Now uh, let's generate a range of number. And what I'm gonna do is np dot arrange function. Let's generate 1 to 27. So it's going to generate a number, series of number 1 to 26. No, if you want to give indexes to something, if you want to count a number, if you want to add a column of indexes where it's incrementing by 1. You can definitely do that. So why all of these functions are useful? They help you create and test data quickly, and they're useful for doing the small calculations. Now, let's say NumPy array operations. Let's say we have a variable called watch hours, and we want to do np.array. We want to build an array of like 12, 15, 10, 20, 18, and you want to print it like watch hours plus 5. What is going to do? Exactly. That is correct. So it's going to add a number 5 to each of the element of this array. So similar to this addition function, you can do multiplication, you can do subtraction, division, you can do pretty much anything you want to. Now there are some aggregation functions as well. Like I wanna know the maximum watch hours, you know, maximum. You can do max, you can do, I guess, minimum watch hours. You can do, I think you can take a sum. So you can type mean, max, sum, standard deviation, pretty much anything. But why does it matter? So it's these functions are used in building a data pipeline and helping analyzing the trends when you are working on building transferring the data. It is also useful to identify outliers and a big value, like there's a user who's binge watching 24 into 7. So you can also do that. There's a way concept called indexing and slicing the data. So since you have an array here, you can just uh, ex you can extract what's at the 0th position, the first users -1. If you wanna extract last user, so you can start with negative, and it would give you 18 from this list. This is called accessing specific elements. You can let's say you want 3 elements from this array, so you can type it like this. If you just want first 3 users, so the code for that would be this. If you put a semicolon, if you keep this blank before semicolon, it would give you everything before index 3. However, if you want users at index from 2 to 4, you can do it like this, 2 to 5. It would give you elements from 2 to 5. Does that make sense? Or am I too fast? So, why? Okay, why is this useful? Why are we doing indexing and slicing? So basically, the reason that we do. So while you write the code, I'll explain why is it useful. It helps break data into smaller chunks. It could be another reason. Or if you are on different system, like instead of Jupyter Notebook, you're using another notebook, it might not show. So there could be multiple reasons, but that's okay. That is something, if you know what you want to use, you can always use it. This is just for simplification. Now there's a cool concept that is called filtering the data. Uh, let's say if you want to highlight those users who are watching a lot, heavy users. So I'm gonna type watch hours, and I'm gonna type watch hours again. I'm accessing the array and the element where watch hour is greater than 15. And if I run this, I would see an error. I see 2 individuals having watch hours of 20 and 80, or the days that I watched more than 15 hours. Boy, 20 hours is a lot to watch in a day. But yeah, that's how you can filter the doesn't. As I've used greater than, you can use smaller than, you can use a range like this. watch hours. Watch hours are greater than equal to 10, and watch hours are less than equal to 20. So this is under filtration. I will see all those days where I watched more than 10 hours but less than or equal to 20. For those of you who are still writing and coping it up, I'll write some comments for you guys, like why NumPy is amazing. It's faster, efficient, it performs math functions in bulk without, loops. It can filter the data. It can reshape the data, convert 1D array into 2D array, all that stuff. Uh, Venkat is asking, he thought NumPy would give something like this filter, but unfortunately it's not there. And I wish I could do anything about it. But if it's not there, then there would be other ways to filter the data like this. Okay, moving on to the next library, which is Pandas. If NumPy is like a calculator, then Python is like Excel, MS Excel, but on steroids. It helps you store, analyze, and clean data. Like think of a database or maybe Netflix homepage that you need to keep track of, like usernames, favorite shows, watch history, subscription type, and they want you to store the data in a table. That's where we use Pandas data frame, which is like an Excel sheet, but inside Python. So with Python, what we can do, we can load data, maybe load massive data sets easily. We can analyze the data. We can do data cleaning, all sort of data manipulation techniques, and we can transform the data. Let me give you a quick example. I'm going to explore a concept from yesterday called dictionary. So I'm going to create a data here and write a dictionary like a user, Alice, Bob, Charlie, and then we have their favorite show, and their favorite shows are. I would like to get a feedback from you guys. So since I'm using this Netflix analogy all throughout the course, is that helping you guys, or should I change examples? So, uh, so everybody knows what the output would be. It would be again the same thing that I input. This is a dictionary that we explored the concept from yesterday. But now, in order to convert, it would be nice. So no, this seems a little odd, and we are familiar with seeing the data in a tabular form. And it would be easier if I can see it in an Excel format or maybe a rows and column format. This looks a little programming type, and I don't want to get into that. So in order to bring it into a tabular format, I would use a library called import pandas, and I'm going to import it as PD this time. Importing pandas library. Once I have imported it, I can convert it into a data frame, or which we call a table. Let's say when I put this data here and I print df, what would I see? So when I do this and I type df and press shift plus enter, I would see a table. Which output do you guys prefer? The dictionary or the data frame? The df. You might be wondering, oh, these are small sets of calculations or programs. Why are we learning lists, tuples, dictionary, and why do we need to, take a mean max average? All those programs and functions that we have learned in last 2 days, you're going to use them in your data engineering course. And this is one of the amazing examples, converting a dictionary into a data frame. Now, once you see this data frame, it all makes sense why we learned dictionary. Does that make sense? Okay, moving on to exploring what Andas can do. It's like you have a list in a regular Python language, you have an array in NumPy. Similarly, in Pandas, you have two types of data structures. First one is series, and the second is data frame. Moving on to data structures, we have series. A series is like a single column of data, like a list, but smarter. And a data frame is like a full table. Let me give you an example of a list. A list starts with PD, since we have imported the library as PD dot series, and we can type anything inside it: 12, 15, 10, 20, 18. So this is like a series that we have just created. I can put this in a variable called watch hours and then print watch hours like this. It would give me the same output. So similar to, how is it different from a list? It also has an index like 0, 1, 2, and you can also name it anything for better readability. Now you might be wondering, what's the difference between a series and a NumPy array now? So NumPy array is designed for efficient numerical and mathematical operations like matrix multiplication, element-wise operation, and linear algebra. While Pandas series, on the other hand, is designed for data analysis like indexing, selection, filtering, and missing data handling. So NumPy for computation, Pandas for manipulation, in simple terms. Coming on to Pandas data frame, let me just take an example. Now let's create a data frame again as data. Let's create the same list of user where the users are Alice, Bob, Charlie, David, Ev. Then we have watch hours, 12, 15, 20, 18, 10, 16. Then we have the country, USA, UK. And then we have the subscription. Like some of them might have premium subscription, could be basic, could be standard, could be premium, basic, standard. So I've created it here and I'm gonna run this part. Yeah, if you're unable to copy, unfortunately, you have to type it out. For those who are using a Mac, I have a trick. You can take a screenshot and then copy from the screenshot. Apple recently launched this picture to text feature that you can directly copy from there. Give me a thumbs up if you have this table in front of your screen. This is a program, and I would like to just show you what you can do with it. There's a library called, um, and I'm going to import it as PLT, let's say. I'm going to create a list. I'm going to put views, and I'm going to plot a bar chart for you. The code is, you see how I had a library within a library here? matplotlib.pyplot, and I've imported it as PLT. I have two lists, shows and views. So these are the number of views, and these are the shows. And I can simply plot a bar chart, and instead of reading the textual data, I can easily see which one has the highest watch time or views. It's Breaking Bad. Does that make sense? It's just to show you that Python has the functionality of creating charts and um, show the data in a visual format through different kind of charting, like line graph, bar chart, a histogram, and plethora of other visual charts. Prasad is asking how to join two data frames. There's a function called pd.merge that is used to join two data frame. Now, there is a lot of data manipulation that we could do, but that's something different for analysis, and we're not going to dive deeper into it. We have half an hour left. Let's move on to our case study for today. Before getting into the case study, I would like to explain you one amazing function, and it's so awesome that everybody loves it. And it's usually asked in a lot of interview questions called functions. And I'm going to explore today. Uh, for example, sometimes you need to do something really quickly without naming a function. Sure. Yeah. Okay, let's get into functions now. Imagine you're running a Netflix party and everybody in the room has their own screen. And you want each person to increase their brightness by 10% so they can see the movie better. It doesn't matter what their brightness is right now, but you want them to increase by 10%. Now we don't want to go to each person individually and adjust their screen. Too much. That's too much work. So instead, you send out a group message saying, hey, you know, uh, hey everyone, increase the brightness by 10%. One message does the task for you. And this is exactly the function that we're going to talk about a map function does for you. So in official terms, map function applies a given function to every item in an iterable and returns a new iterable with the modified value. Oh, that is complicated. That is something you would have found if you have Googled it, but I'll simplify it for you. Let's say we have a function, f, increase brightness. I'm sure everybody is familiar with these functions now. And we're going to use a return function like x plus 10. What it's basically doing, it's adding 10% brightness. Now, let's say I have a list called screens where my friends are watching the movie. Some of them are on 30, 50, 70, and 90. And these are, let's say, brightness levels. So what I'm going to do, I'm going to call a function called map. And I'm going to call this function like this, increase brightness, and provide the list as an argument like this. And I would like to store the value in a variable called new screens like this. And once I'm done with that, I'm going to print the new list, new screens. And when I run this, you would see a number 10 has been added to each of the variable in screens. And it has become from 30 to 40, 50 to 60, 70 to 80, 90 to 100. So instead of running a loop, you can just directly use a function like this, a combination of user-defined function and map function to create this kind of list. See, I took a long pause. I was like, oops, am I covering oops concepts? No, not today. Today is all about Python for data engineering. So sometimes you need to do something quickly, and you don't want to name a function every time. And let's say your friend comes to your party and you say, hey, can you add 5 more minutes to everyone's screen time limit? Everybody is able to see some time in a limited time frame. So you don't need a fancy function for this, and you just want to do something really quickly. That's where a lambda function comes in. A lambda function is it's a small anonymous function that is used to do tasks quickly. Let's say we have a list called watch time where we have 60, 90, and 120 watch times. It's watch time in minutes. And then we have, now I'm going to write the function. Since we've learned map function, map is sending a group message. But instead of creating this function separately, I'm going to create this function right in the middle parenthesis of map, but with the help of lambda. So how it's work? I'm going to write lambda x plus 5, comma, and I'm going to pass on the list here. And I'm going to put it in a variable. Update it times. And when I run this, I'm going to see something like this. Instead of creating a separate function, I have used a combination of map and lambda to create a function of its own. To give you a
Oh,
small breakdown of this, how it's working. In the first iteration, we have 60 here as X because it's taking the data from this list, watch time, and it's going to do. It's going to do 60 plus 5 and put it in the updated list. Then it's going to take 90, add 5 to it, update, and it's going to put it into updated list. It's going to take 120 and add it, and it's going to put 125 to the updated times. And when you print it, you would have it done in one single line of code. But this lambda function, the only difference between a lambda function and a user-defined function here is we can use this function anywhere we want to and any number of times we want to in the program, while this lambda function will only be used in this one. You have to rewrite this line again in order to replicate the same logic. But for this one, you just have to write it once. Somebody asks, so map basically iterates only over a list? Yes, probably. It basically iterates over a series or something, a numbered column that you can have. You can convert your data frame you can convert your user data frame into a list. That's a different way of converting it. But yeah, you can convert it into a form of list and use it here. Cover a mini project for you guys now. And I would need your help in it. So the project is build your own Netflix or let's say movie recommendation system. So I'm gonna use everything so that you have a practical application of it and try to understand what I'm doing. So here, we have few goals. Every project statement comes with an objective. The objective is, imagine you are a VP at a streaming-based platform like Prime or Netflix, and tonight you have a executive movie night planned. Somebody is coming over and you have a movie night planned. But there's a problem. Some of the movies are too short. So the first task is we want feature length films only. Films that have a certain length. The second task is you need to rank them by rating. You don't want to show movies that are not interesting to your guests, right? So we want best of the best. And thirdly, you must choose. So they don't have whole night. So you must choose the top 3 movies for the ultimate watch list. Is the problem statement clear to everyone? So your mission is to build a Python powered system to filter, sort, and recommend movies like a true data engineer. Are you ready? Perfect. Let's move on. So I'm gonna start with creating a list of movies that I have here. And the movies are like this. Now what I'm doing, I'm creating a set inside a list. So how it's gonna work like this. The first movie is Inception, and the rating is 4.5, and the runtime is 148. The second movie we have is Toy Story. The rating is 4 and the runtime is 81 minutes. The third movie that we have is The Matrix. The rating is 5 and the runtime is 136 minutes. The fourth movie that I have is Frozen. The rating is 3.8 and the runtime is 102. The other movie is Interstellar. The rating is 6 and runtime is like 200 minutes. And the last movie that we have for our guest is Avatar, 4.8, and the runtime is 162. So what it is? So this line creates a list. So here basically we are defining a list of movies. This line creates a list named movies containing 6 tuples inside it. Sorry, it's a list inside tuple, the other way around. And the structure of each tuple is index 0, the movie name, is the movie title, which is a string. Index 1, it's the movie rating, a float, data type. And the index 2 is an integer, it's the movie duration. Clear? Clear so far? Let me comment it for you. Make sense? When I run this, I have the movie list now. So the second step is filter out movies that are shorter than 90 minutes. So what I'm gonna do here is movies than 90 minutes. So for this, I'm gonna create an empty list called long movies because I'm gonna store the data in it. So I'm not putting anything in it. So for movie in movies, I'm gonna put a condition if movie, what's the location of the duration is. So I'm gonna put 2 here. If the movie duration, so I'm gonna pointing out to the duration column is greater than 90 minutes. So what I'm gonna do, I'm gonna append long movies dot. I'm gonna put that movie inside this list. Make sure you follow me. Is that clear? How we are filtering it? Let me come again. So to create a list of long movies that only includes movies with duration of 90 minutes or more, what it's going to do, it's going to go into this first set and take inception 4.5, 148, and it's going to check what's at position 2. At position 2, it's 148. Is it greater than 90? Yes, it's greater than 90. So what it's going to do, it's going to put the movie here, long movies, and append it in this. Append, I mean, since it's empty, it would be Inception, The Matrix, Frozen, and Interstellar, and Avatar. So when I run it, I would have this output for all of it. So if when I print long movies, I should have a list of movies that have a duration greater than 90. We have covered this concept before. I'm going to give you another amazing example. Let's say instead of 90, I put 190. What do you think the output would be? So what it's going to do, it's going to only take the movie that has greater than 190 watch time. Make sense? Now, in the second step, this was the step one. We had 3 questions. We have cleared the first step. Now, step two, what we had to do, we have to sort the movies by rating. So here we're going to use a concept called lambda that we just covered and a function called sorted. How it works, sorted is a function similar to lambda map apply that map that we've learned. What it does, it sorts the data into the order that how we define it. Okay, so we would like to sort long movies. Okay, let me just do it 90 again, and let me just print it again. So just be able to clear. Now we have this list. Make sense? We want to sort this list by their duration, watch duration. So now we have sorted long movies. I'm gonna do long movies, comma. The key that I'm using is lambda movie because we would like to sort the movie by rating. So it's one, and it says reverse equals to true. So it means we would like to reverse it in a descending order. So when I run this, it would give me output something like this, where I have movies that are sorted by in the descending order. So I would put this output in sorted movies and print it like this. So how it works, to sort the filtered list, like long movies by the movie rating in descending order, which is highest rating first. The built-in function sorted creates a new sorted list. The key function here is lambda. The lambda function tells the sorted to use the second element of each tuple, that is rating of the sort key. So here we are, what this key is doing, this is a syntax of sorted. Let me see if I can get this. Yeah, you see we have a syntax sorted. The iterable that we want is long movies. Then we have some wild characters, key on what key that we want it to be reversed. So the key here is our rating that we are fetching in every iteration of this lambda. Reverse is true. So the default is false, which iterates in an ascending order. But when we do it through, it sorts the data in a descending order. And step three was, since we have done sorted the movies, now we have to display the top three movies. So to display the top three movies, I'm gonna print first top three movies to watch. And here I'm gonna run a loop like for I in range. I'm gonna explain what I'm doing. Oh, we have sort movies here. Okay, before running it, I would like to explain you what I just did. So this loop basically prints the top three movies based on the sorted order. How it does that? You might be familiar with the print statement. This prints the top three movies to watch. Now, how the loop works for I in range. This is the range that we are talking about. What it does, uh, we 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 had a concept like this. If I do range, you know, 0 to 7, it would run from 0 to. We are familiar with this concept, right? But here, what it's going to do, it ensures that if there are fewer than three movies, the loop will only run for the available number of movies. So in our case, the length of the sorted movies. So this function, what it does, it gives me the length of the sorted movies, 5. So in our list, there are 5 movies. So minimum 3. So the minimum from 3 and 5 would be 3. I'll show you how. Minimum function calculates the minimum between the two, like this. And so now the range function works as like this, 3. So if I run this function range 3, it would mean that it would run from 0, 1, 2, which means there would be 3 iterations. Does that make sense? It's a little complicated. It's the end of the course, so we are okay being complicated. And there might be a few things that you might not understand, but then in the next iteration, it's going to take this I parameter, sort movies, and it's going to put this f string movie, rating, and duration. And it's only going to run for 3 times. Basically, it's fetching the top 3 movies from it. And if I run this, I have the final output. Top 3 movies to watch are Interstellar, based on rating and duration, The Matrix, and Avatar. So to have this in one go, this is how your project would look like. Yeah, we have output here. With that project, this session comes to an end. Let me know how you liked it.